Bismillahirrahmanirrahim. Today we are going to discuss question number 9 of exercise 1.1. Indicate whether each table specifies a function y is equal to f of x. Now look at this part A. Here the value which we input into the function is called domain, and the value which the function gave us is called range. So look here, these are pre-images and these are images. For every pre-image there is a distinct image, there is a single line, so it is a function, it is one function. Look at this part second one, this is also one function. Now look at part third one. Here 5 and 6 have the same pre-image, so it is not a function. In the function there should be a single line from each element in the domain, so that's why. Now look, the question 10, indicate whether each of the graph specify a function or not. Look at this one part. Here we will check it by vertical line test. When we draw a vertical line on this line, so this line touch only by single point, so it is a function. Look at the second part. If we draw a vertical line, so it also touch this line by a single point, so this is also a function. But if we draw here a line, so it will touch the graph by more than 2 points, here 1, 2 and 3 like this, so it is not a function. By vertical line test, the graph of a given curve will be function if it is if the vertical line touch the graph by a single point. Now come to the next question. Question 11, determine domain and range of the following function. The first one is y equals to 3x plus 4. In this question we will give to this x the values which is domain, and the y value will be find which is the range. So we will now going to discuss it. Question number 4, part first, y equals to 3x plus 4. Its domain is set of real number, because here we put the value of x, let us suppose 0, 1, 2, 3, minus 1, minus 2. Its answer will be a real number, so its domain is the set of real number. Now for range, let y equals to 3x plus 4, shift this 4 to the left side, so we get here 3x. Now divide both sides by 3, cancel with this, so x is equal to y minus 4 divided by 3. Now if we put any real number here on place of y, it will give us a real number, so its range is also set of real number. Now part 2, f of t equals to t square plus 5. Let y equals to t square plus 5. Now put here the value of t, any real number, so it will give us a real number, so its domain is the set of real number. Shift this 5 to the left side, so y minus 5 equals to t square. Now take square root on both sides, y minus 5 under the root equals to t square under the root, square root cancel with t, so we get t equals to y minus 5 under the root. Now look, if you put the value of y 0, so we will get 0. But if we put the value of y minus 1, suppose minus 1 minus 5 under the root, we get minus 6 under root. It is not real number. Because it is complex number, iota will become in the answer. So it means that when we put the value of y 0 or greater than 0, so it will give us value. So its range is y is greater than or equal to 0. When there is a square root, so we will find that number by which it will give us a positive number. If it becomes negative like this, so then it is complex, it will not be the answer of this. Part 4, part C. Surface area equal to f of r, it is the function in r, 4 pi r square. So let y equals to 4 pi r square. Now when we put any real number on place of r, we will get a real, so its domain is the set of real number. It cannot be undefined by any number. And now for range, divide both sides by 4 pi, so here we get this 4 pi cancel with this 4 pi, we get here r square equals to y divided by 4 pi, take square root on both sides. Now this root cancel with this, we get r equals to y divided by 4 pi whole under the root. Now if we put the value of y 0, so we will get 0. 0 is a real number. And if we put minus 1, so we will get the answer in minus. So it is not a real number, it is complex. So the range is what? Y greater than or equal to 0 is the range. When we put the value of y less than 0, minus 1, minus 2, minus 3, then it will become a complex, not a real. Composite function. If f of x and g of x are two functions, then f of g of x or f of g is called the composite function. Come to the exercise. Question number 4, part A. F of x is equal to x square plus 1, g of x is equal to 2x. Find f of g of x and g of f of x. So solution. F of x is equal to x square plus 1. Put the on place of x this g of x and here the 2x. So we get f of g of x equals to the x value will be the right side here 2x. 2x square plus 1. So we get f of g of x equals to 4x square plus 1. Now g of x is given that 2x, so g of put on place of x f of x 2, and on this x place put the f of x value, which is x square plus 1. So we will put here x square plus 1, multiply this, we get 2x square plus 2 times 1 is 2. So we have find these two. Part D1 is given that f of u equals to u minus 1 divided by u plus 1 and g of u equals to u plus 1 by 1 minus u. We will have to find f of g of u and g of f of u. So solution, we are given f of u equals to u minus 1 divided by u plus 1. So put on this u place g of u. So we will write it f of g of u. And here on this u and on this u we we will put the value of g of u, which is u plus 1, 1 minus u minus 1, and here u plus 1, 1 minus u plus 1. On this u place we will put the value of the g of u, which is this u plus 1 by 1 minus u, here and here. Now we will simplify it, we will take the LCM of the denominator, which is 1 minus u here. So we get u plus 1, multiply this with this 1, so 1 minus u, and in the denominator here the LCM is 1 minus u, so write it u plus 1 and multiply this 1 minus u with this 1. Now look, here we get u plus 1 minus 1 into 1 we get minus 1, and minus 1 into u we get plus u, in the 1 minus u. Now in the denominator u plus 1 plus 1 into 1 we get 1, and plus 1 into minus u we get minus u divided by 1 minus u. Now look, this minus 1 cancel with this minus 1, and this minus u cancel with this u, this 1 minus u cancel with this, so here we get 2u, and here in the denominator we get 2, this 2 cancel with this, we get u. So the value of f of g of u is u. Now we are going to find g of f of u. G of f of u. So this is g of u. So here on place of u we put f of u. Here on place of u and this u we will put the value of f of u. So we can write it u minus 1 divided by u plus 1 plus 1 divided by 1 minus, on this u place we will put u minus 1 divided by u plus 1. Now take the LCM here, multiply this with this u minus 1. When this is multiplied with this 1 we will get u plus 1, and in the denominator we will write u plus 1. Similarly this u plus 1 is multiplied with this one, we get u plus 1 and minus u minus 1, and in the denominator we will get this u plus 1. This u plus 1 will cancel with this u plus 1. Now look, this minus 1 cancel with this one, here we get 2u, and in the denominator we can write u plus 1 minus u plus 1. This u cancel with this u, so here we get 2u divided by 2, 2 cancel with 2, we get u. So we got that f of g of u is equal to g of f of u, because both are equal to u.